All right. Boys and girls, are we okay with the first calculation? Yeah. The second one is can we be quiet? Second one is find the current, right? And it doesn't say 2.3 ohms, right? So I'm going to take the value on my calculator, divide by 2.3. Okay. And I get, whoops. Okay, I have to actually say divided by 2.3. Okay. So I get 1.471 amps. Okay. And then it says, what is the current that flows? Then it says, what is the power dissipated? Okay. Well, power is easy, right? Power is, I'm going to choose to use V squared over R. Okay. There's lots of ways to do it, but I'm going to use V squared over R. You could use I times V. Okay. I'm going to use V squared over R, so that's going to be, actually, you know, I'm not. I'm actually going to use I squared R. The reason is that I've got the current on my calculator right now. That's the current value anyway, right? Okay, so. Okay, times 2.3. Okay, so remember, watt is the unit of power. Okay, then it says, what is the total electrical energy generated? Do you recall that power is work over time? Do you recall that? Power is work over time, not in the data packet, because the data packet kind of sucks. Okay, but that means that work or energy is just power times time, right? And so I can just multiply this as 4.9764 joules per second, right? That's what a watt is. I can multiply how many seconds? 0.621 seconds. Okay, so I just multiply by 0.621, and I actually get 3.09 joules. Right? Then it says, if the magnet moved 3.75 centimeters to affect this change, okay? This is the other way you can use the word effect. Sometimes it's a noun, like what is the effect of getting the magnet closer to the Hall effect probe, okay? But it can also be used as a verb, and this is, it means to cause, okay? So I didn't use the wrong letter there, okay? So if it moved 3.75 centimeters to affect this change, what was the average force that resisted the motion? I'm going to use this principle that if this was the electrical energy generated, that the mechanical work needed to do that was the same. And mechanical work is force times distance, right? So I'm going to say force times 0.0375, that's the distance they say it moved, right? Equals this work. Right? Because this is meters. Remember, a joule is a Newton meter. So if I divide that by 0.0375, that means there'd actually be an 82.4 Newton force. Did I get those right? Yeah. 82.4 Newton force opposing it. Okay, so, and the force always opposes the motion because, of course, if it attracted the magnet and brought it in, you'd be getting like energy from both ends, which would violate conservation of energy, right? So this is magnetic damping. That's what we looked at last time, didn't we? I showed you examples of that, right? This is how PSU stops the falling drop tower thing, right? They've got this big magnet that generates electricity that opposes the motion, right? Okay. Are we okay? Are we good on that? I hope so.